Welcome back to the second lesson in Unit 3, and we are going to take what we did in the first unit, factoring, and we're going to take one step further, and we're actually going to solve quadratic equations now, okay? So we are going to first quick review of how to factor some trinomials. Okay, so first one, we have this is a complex trinomial. So you know what? Give it a try, and I'll show you the answer in a few minutes. Okay, so these are the answers for these two warm-up questions. Hopefully you got them right. Again, you can use any method that I showed you the other day, or if you learn some other methods, that's perfectly okay as well. As long as you can factor, it doesn't really matter which method you use, okay? I don't really care. All right, so now we are going to actually solve some equations. We actually seen this before in the previous unit when we solve radical equations, because when you square both sides, or when you try to get rid of the square root, sometimes you do end up with a quadratic equation. So really, we've seen this before, okay? So in general, when you factor, you get something like that. Obviously, it doesn't have to be just x. It could be 2x, 3x, right? It could be 5x plus 5 times 2x minus 3, something like that, right? But anyhow, in general, once you have a factor, it means either the first set of brackets equal to 0 or the second set of brackets equal to 0, because anything times 0 is 0, okay? So that's how we are going to solve quadratic equations. So here is one simple example right here. We have x squared minus x minus 6 equal to 0. So we can actually factor this quite easily. This is a simple trinomial. So we have x and x there. We're looking for two numbers multiplied to negative 6. Okay. Multiply to negative 6 and add to negative 1 right here. So we know it's going to be negative 3 times positive 2, and they're going to multiply to negative 6 and add to negative 1, and therefore either this equal to 0, which means either x equal to 3, or in this case, x could equal to negative 2. Okay, so that would be the solution. That's it, right? Either one of them is a 0. If any one of them is 0, then your product is going to be a 0. Okay, so to solve quadratic equations, you make one of the brackets 0, then you're done. Okay, now that's a simple example where it's everything is set up for you. Now obviously it's not always like that when you have quadratic equations. For this example right here, you can see it does not equal to 0. So the steps that we need to take, the very first step is to set the equation equal to 0. Now what I'm going to do here is I'm actually going to expand on the left hand side first. Okay, I'm going to expand on the left hand side. So when I expand, you should get 2x squared. Multiply, you do your rainbow. Okay, so then you should end up with minus x minus 3 equals to 3. Okay, once you have it expand, follow the steps. First step, set the equation equal to 0. So what I'm going to do is I'm going to move this 3 to the left, so you end up with 2x squared minus x minus 6 equal to 0. Okay, so when you solve linear equations, to solve linear equations, you isolate for x. To solve quadratic equations, the first step is to make it equal to 0. So check. Step 2, factor the non-zero side. So now I need to factor this. Okay, so you can use decomposition method, AC method, or you can guess and check. This time I am going to guess and check. So it has to be 2x and x, right? I mean, that's the only way to multiply to 2. For 6, it could be 2 times 3 or 6 times 1. And this time it's going to be negative 2 times positive 3. And they will actually add to negative 1, so that's perfect. 3 times negative 2 is negative 6, so this is fine. So factored, okay. Number 3, use the factor property to set each factor equal to 0. Well, we just did, I guess. And then solve each factor. So now that's done. Step 4 is to make this 0. So you can say that 2x plus 3 equal to 0. And or x minus 2 equal to 0, and you solve them separately. Okay, so in this case, you minus 3 on both sides and divided by negative 3, you end up with negative 3 over 2. In this case, you move 2 to the right, you get x equals to 2, and you're done. Okay, now number 5, you checked for extraneous roots. Okay, sometimes it does happen. and then you check the solution in the original equation. So what that means is, what you do is you plug in these two numbers into the equation. So I'll show you. I'll check for the 2. So what we can do is we go 2 times 2 minus 3 times 2 plus 1. Is that equal to 3? Well, let's check. 2 times 2 is 4. 4 minus 3 is 1. 2 plus 1 is 3. 1 times 3 is equal to 3. So we're good, okay? And you do the same thing with negative 3 halves. That's 2 times negative 3 over 2 minus 3 times negative 3 over 2 plus 1. Does this equal to 3? Well, we can check. This is negative 3 minus 3 is negative 6. This is negative 1.5 plus 1, so that's negative 1/2. And negative 6 times negative 1/2 is indeed 3, so that also works. Okay, so then we just checked out our answers, and they are perfectly okay. Okay, so that's how you solve quadratic equations. Okay, quite easy, not too challenging. Okay. Now we're gonna move on to next slide, next page. Here we are gonna solve these equations involving a common factor. So again, we follow the steps. First step, move everything to one side and make it equal to 0. Okay, so I'm gonna move everything to the left by adding 30x. Now I see that's a 3, that's 30, that's 75. I can actually factor out a 3. So you end up with x squared plus 10x plus 25 equal to 0. This is a simple trinomial, so I can actually factor this one quite easily. I need to think about what multiplies to 25, and those two numbers add to 10. They would be positive 5 and positive 5. So these two brackets are actually the same, right? You end up with a perfect square. So you just need to solve for one single set of brackets, and that's going to be x equals to negative 5. Again, you can always plug this number back to check. I will do it here, negative 5 squared plus 75, and we want to see if this is indeed equal to negative 30 times negative 5. Okay, so negative 5 squared is 25. 25 times 3 is 75, so we end up with 75 plus 75. Negative 30 times negative 5 is 150. Indeed, 75 plus 75 is 150, so we know we did it right. Okay. This one is not a trinomial, but it's still a quadratic equation. Again, we call this a quadratic equation because it has an x squared term. Okay, as long as the highest exponent that you see is a 2 and it's a polynomial, then it's quadratic. Okay, so this is a quadratic equation, so we're going to follow the steps. Again, the very first step is move everything to one side and make it equal to 0. So I'm going to again move it to the left, and the reason why I move it to the left, not to the right, is because I always want to keep my x squared term positive. Okay, that's just my personal preference. Now from here, this is not a trinomial. However, we do have a common factor. It is 5x. So we can factor the 5x, and you end up with x minus 4 inside the brackets. Okay, now you can write this like inside the bracket as well, so you actually have two solutions. So you need to think about, for what x value is this bracket or this set of bracket going to equal to 0? Well, if x is 0, 5 times 0 is 0. For what values of x are we going to make the second set of brackets 0? Well, in that case, it's going to be negative 4. Okay, negative 4 plus 4 is 0. So there you go. They are your solutions. You can plug in and check, just in case, right? Just in case. I know it's going to work in this case, so I will skip checking, okay? But you should always check, okay? Especially at very first. You know, you don't feel confident, maybe, in solving the equation, so you can always check. I think after a while, you feel pretty good about yourself, then, you know, if you want to skip that checking part, that's fine. Okay, radical equations. This is what we did in the previous unit. Hopefully you still remember what to do. What we need to do here is, remember, we have one single radical, therefore we need to isolate for the radical. So I'm going to move 4 to the right by subtracting 4. Okay, and now I can square both sides. I can square this, and I can square that. So then we can expand. This becomes 6 minus x. On the right hand side, if you expand, again, common mistake, people think this is x squared plus 16. It's not, okay? You need to have a middle term, minus 8x right there, okay? So again, x minus 4 square means x minus 4 times x minus 4. So make sure you do your expansion, okay? Distribution property. Okay, so now once we have this, we can move everything to the right. You can see this is simply just a quadratic equation. So I'm going to move everything to the right so I can keep my x squared positive. That's going to be add x there, so minus 7x, and then minus 6 on both sides, so I get a positive 10. I can factor this. I should get x minus 5 times x minus 2, right? Negative 5 times negative 2 is 10. Negative 5 plus negative 2 is negative 7. So we will end up with two solutions, 5 and 2, right? 5 minus 5 is 0, 2 minus 2 is 0. And there you go, finished. Okay, here is a more challenging example because you actually have, it's actually a rational equation, okay, rational equation, which we'll deal more, okay, we'll do more about these. We'll actually look more into it later on in the school year, but it's actually pretty simple, okay? When you solve rational equations, what you need to have is common denominator, okay? So what you need to do first, though, however, is to factor this, because that one is definitely factorable, okay? So we can factor that. This is going to be x minus 5 times x plus 1. Okay, that's the common factor right there. Oh, sorry, that's the factor. Those are the factors of that. Let me just double check. Yes, that's right. Okay, so now what we need to do is we need to have a common denominator. Okay, so we have actually three different denominators right here, or three different binomials: x minus 3, x plus 1, and x minus 5. So when you have common denominator, that means we need to have well, all three of them. Okay, so it's going to be x minus 3, x plus 1, and x minus 5. That is the common denominator. Okay, so we can see for the first set of fraction right here, we are missing x plus 1 and x minus 5. That means I need to multiply the 5 with x plus 1 and x minus 5. For second fraction, I already have x plus 1. So what's missing is the x minus 3 and x minus 5. So what I need to do is I need to multiply the 3 by x minus 3 and x minus 5. Okay. Now on the right hand side, you have x minus 5 there already, and you already have x plus 1. So really the only thing you need to multiply by is x minus 3. So now we have the same denominator on both sides. Once you have that done, the denominator does not matter anymore. Okay, they do not matter anymore. So, well, they do kind of, but we'll get to that in a bit. Okay, so from here we can kind of just forget about the denominator. So I'm going to expand the numerators. Okay, so I have 5 times, this is product of binomials. I'm going to multiply that. I get x squared minus 4x minus 5 minus 3 times x squared minus 8x plus 15. And the right hand side, you should end up with 30x minus 90. And again, I can expand this even more. I should get a 5x squared minus 20x minus 25 minus 3 times x squared is 3x squared. Negative 3 times negative 8. So be careful, it's both negatives, so plus 24x. Negative 3 times 15 is negative 45 equals 30x minus 90. Now you can see this is a quadratic equation, right? Because the highest exponent, the biggest exponent that you see is a 2. And it's a polynomial equation. So 5 minus 3 is 2x squared. Okay, so I'm going to collect all the like terms. Cross out. Negative 20 plus 24 is positive 4. But I need to move 30x to the left, so I need to minus 30. So positive 4 minus 30 is minus 26x. Okay, that's done, done, done. Negative 25 minus 45 is negative 70. But I need to move negative 90 to the left by adding 90. So negative 70 plus 90 is 20. Okay, so that's the equation, and now you can see all these numbers are multiples of 2, so we can actually factor the 2 plus 10 equals 0. And oh man, I must have made a mistake somewhere. Okay, let me check. Okay, so it doesn't look like I made a mistake. I think everything is fine. So I guess it's just a bad example that I came up with. Okay, the reason why I think I thought it was wrong because this is not factorable. Okay, however, okay, we can come back to this question later on because we will be solving equations that are not factorable in the future. Okay, so but for today, we can solve this. So I'm gonna leave it right here. Okay, but after the next lesson, we will be able to solve equations that are not factorable. Okay, so but for now, I guess there's nothing we can do about this. Okay, so I'm just gonna leave it right here. Okay, we'll come back to it later. Okay, because we can actually solve quadratic equations that are not factorable. Not yet though. Okay, so we'll wait. Okay, we'll wait. Okay, now we can work backwards. It says write a quadratic equation with the roots 2/3 and -1/3. Write the steps that you used. Okay, so these are the answers, and we are looking for a quadratic equation for it. Okay, so the easiest way to do this is obviously then I can say that that means when I factor, I would have x minus 3/2 or 2/3, right? Because then that means 2/3 is the solution times x plus 1/3, right? Because the solution for that would be -1/3. That's how you make that 0 equal to 0. Now, obviously, we probably don't like to have fractions when we multiply. So what we can do is, like the AC method, what we can do is we can actually bring this denominator to the front. So this is actually, we can rewrite this as 3x minus 2 and 3x plus 1. Okay, I simply bring the denominator to the front. And now this is much easier to expand. That's 3 times 3, so that's 9x squared. 3 times 1 is 3. -2 times 3 is -6. So minus 3x minus 2, -2 plus 1. And there is the answer. Okay, looks much nicer than those fractions. Okay, so not too difficult. Really, all you need to do is put this into the factor form. As fraction, that's fine. But then we can, again, get rid of that fraction, kind of, by putting the denominator in front of the x. And that's going to work beautifully, just like that. Okay, so these are solving quadratic equations. Now, of course, we are going to deal with some word problems. Okay, I mean, that's what math is used for, right? We are going to solve some, word problems. So therefore, I'm going to see some word problems. Okay, so here, let's see. It says the length of a rectangle is 3 centimeters less than twice the width. Okay, so we have length and width of a rectangle. It says find the dimensions of the rectangle if the area is 20 square centimeters. Okay, so this is the area. Now it says length is, right, is means equals 3 centimeters less than twice the width. So twice the width and 3 centimeters less than that. So length is actually the same thing as 2w minus 3. Okay, so hopefully that makes sense to you. So based on this, I mean, what we have is we know the area is 20. And don't forget, area of a rectangle is simply length times width. So based on this, we can say then, okay, well then that means 20 is equal to length times width. But the problem with this equation is we have two variables. Okay, we have L and W. And we can solve this equation with two variables. However, we did come up with this, right? We say that length is 2w minus 3. So then what we're going to do is we're going to replace L with 2w minus 3. Now we have one single variable. We can actually solve this. Okay, so what I'm going to do is I'm going to expand the right hand side first. We end up with 2w squared minus 3w here. Now this, you can see, is a quadratic equation. I can make it equal to 0 by moving 20 to the right. And now I can factor this. Okay, So again, because 2w squared, it has to be 2w and w. Now for 20, it could be 1 times 20, 2 times 10, or 4 times 5. Let me see here. I think it's going to be 4 times 5. So negative 4 and positive 5. Yes. Okay, 2 times negative 4 is negative 8. 5 times 1 is positive 5. Negative 8 plus 5 is negative 3. 5 times negative 4, negative 20. This is perfect. Okay, so now we can solve for w. Okay, so I think this one's easy. This means w is equal to 4. Okay, this one you can actually solve it by making it equal to 0. So move the 5 to the right. You get negative 5. Divide both sides by 2. You get negative 5 over 2. Okay, now the unit here is centimeter. Now can both of these be the solutions? Let's think about this. W represents the width. Can width be negative? I guess not. Okay, so we will need to reject this answer, and we say that width is actually 4 centimeters. Okay, and now we can find the length quite easily because we found width to be 4. There are two ways to do this. We have this equation right here. So once we know width is 4, we can say that, okay, well then 2 times 4 minus 3 will give me the length, which is 2 times 4 is 8. 8 minus 3 is 5 centimeters. So that's one way of doing this. Or you can think about the area. It says that the area is 20. Well, if the area is 20, width is 4, well, the length is just going to be 20 divided by 4. So that's going to be 5. Okay. I'll ask you to try number 2 yourself. Okay, hopefully that's what you have as a setup, right? Length and width. The area is 130. It says the length is 1 more than 5 times the width, so 5w plus 1. Okay, so once you have this, again, you can just follow what I just showed you there. We actually know the area is, again, length times width. And again, this has 2 variables, so I'm going to replace the length with this expression right here. So then we only have one single variable. We also now know that the area is 130. So I'm going to replace A with 130. I'm going to replace L with 5w plus 1. And the w is still w. Now once I have this, I can actually expand. So this is going to be 5w squared plus w. Now we have a quadratic equation. Therefore, we can make it equal to 0 by moving 130 to the right. And now we can factor this. Okay, now this might not be that easy to factor. Let's see. 5w squared, it has to be 5w and w. Okay, there's no other way around it. Okay, now 130, there's so many possibilities now. Okay, so now I need to think about this. 10 and 13. 10 and 13. No, definitely not. I think it has to be a small number and a big number. I'm thinking 26 and 5, and that is the one. Okay, so minus 26. No, plus 26 minus 5. 5 times negative 5 is negative 25. 26 times 1 is positive 26. Negative 25 plus 26 is definitely positive 1. There you go. 26 times negative 5 is negative 130. Okay, so those are 2 numbers. So in this case, you can say that 5w plus 26 is 0. So for w, by moving 26 to the right, divide both sides by 5, you get negative 26 over 5 centimeter. Again, we need to reject this answer because the length or the width cannot be negative. Whereas this one, well, that one's easy. W is 5 centimeter, and this indeed is going to work. Okay, so then again, we can find length quite easily by plug into the length equation. Length is 5 times width plus 1. 5 times 5 is 25, plus 1 is 26 centimeter, and that is your length right there. Okay. All right. Last example. Again, I'll ask you to try it. Okay, hopefully that's the setup that you have. Here's the triangle. The base is on the bottom. That's the height. And we know the area of the triangle is base times height divided by 2. It tells us that the base of the triangle is 3 meters longer than the height, right? So that's why I have this expression right here. B is equal to h plus 3. Okay, now once we have this, it tells us that the area is 35 meters squared. Okay, so then area is 35 we have the base. Again, we have two variables, base and height. Again, we don't want to have two variables. What I'm going to do is I'm going to replace the base with h plus 3. You could write 3 plus h if you want, okay? I just prefer to have the variable first. That's usually the convention. Okay, so now I have this equation. Now I do have a divided by 2 here. Recall, we can get rid of that by multiplying both sides by 2. Okay, so then I get 70. Okay, 2 times 35 is 70. And I can also expand the top part. Okay, so h times h is h squared plus 3h. Quadratic equation means I can make it equal to 0. Okay, so by moving 70 to the right, minus 70, this is simple trinomial. I'm thinking about two numbers, multiply to the negative 70 and add to 3. They would be positive 10 and negative 7. Okay, so that's how you factor this one right here. And this is easy. That means h is either equal to negative 10 or h is 7. Obviously, again, height cannot be negative 10 meters. So we know that the height is going to be centimeters, 7 meters. Now, once we find the height, we can find the base. Or actually, it does not ask us to find the base. It only says find the height. But if you want to find the base, it's easy, right? Base is equal to height. Again, we plug into the base equation. Height is 7 plus 3, so base is 10 meters. I know it didn't ask you, or it didn't ask us to do it, but if it did, okay, that's what you need to do. All right, that's it. Hopefully this wasn't too challenging for you. Again, I apologize for this example right here because this is not factorable. But again, we will be learning on how to solve non-factorable quadratic equations shortly. Okay, do your practice questions and let me know if you need help. Good luck.